Hey everybody, this is Larry. This is day 25 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Today we have count of interesting. I can't even read today, so maybe we do have a poem. But yeah, I'm getting ready for my trip still. Today I just mostly packed, so I didn't do much, so that's my quick update for those of you who've been following along my training. Excuse me, I'm still like, I don't know if you could. I'm not gonna zoom in on it. It's not that interesting, but you can. My eyes are red and crying because allergies is just kicking my butt today. So no bueno anyway. But yeah, I don't know. Let's take a look at today's problem. We have 2845 count of interesting subarrays. Read correctly this time. All right, let's see. You're given serial indexed array nums, an integer modulo, and an integer k. Your task is to find the count of subarrays that are interesting. A subarray is interesting if the following holds. Count is the number of indexes I in the range LR such that num sub I modulo is equal to k. Then count modulo is equal to k. Wait, what? Is that like two layers of stuff? Count is the number of indexes in I such that num sub I. Okay, so I mean this part is fine. Then count is equal to k. Okay, I mean, so like if k is equal to 1 is kind of weird. Oh no, it's modulo, right? So that means that they want one number in the array and one. Okay, in this case there are two numbers in the array, only one. Okay. Okay, and in this case, n is 10 to the 5th, so it is actually big, right? I mean, I think this problem is not that. It's hard to read, but I don't think the algo is that tricky. It's just like a very weird constraint, really, right? That you have to kind of do this double layer thing, and we just have to parse it correctly. Which, honestly, maybe I'm not parsing correctly quite yet, right? But yeah, okay. I'm reading the example right now just to make sure. So okay, so this is also a terrible example. I don't know why they don't give like an example that just allows you to understand it. I mean, maybe there's nothing that like crazy algorithmically. It's not like going to give the problem away, but okay, this one maybe is a little bit more interesting, right? So okay, 3903. Okay, that's a subarray. Oh, this is 02. Huh. But it is to say that, okay, so here, if I'm just looking at this subarray, 3, 1, and 9, there are two numbers, but 2 mod 3 is equal to 2. So, okay. And this is like some inception double layer thing that is always a little bit tricky to read correctly. But I don't think this is that difficult per se, if you have a lot of sliding window things. Is it sliding window or is it... I think this is. No, I don't know that it is sliding window. In fact, I don't think it is sliding window. It could be sliding window. I don't know. I feel like people do. I feel like in general, a lot of people do crazier stuff with sliding windows than I do. So I'm not as good in sliding windows as other people do, because sliding window does have a component of greedy and invariance that sometimes I'm not good at. But anyway, for this one, I think it is just about counting, right? I think you can do everything. If my understanding is correct, then you could do everything with a prefix sum, right? Yeah. Because the numbers itself don't change. So the first observation is that the numbers themselves don't change. And what I mean by that is just that, well, if the numbers don't change, then the number modulo don't change, right? So there's nothing like what I mean by that is that if you have a subarray, the numbers, like there's no interaction between the numbers, right? So like if you have one, if you add a number, you subtract a number, it doesn't impact the rest of the array and its composition. The only thing that it affects is the number of count. And here I like to kind of go over the way that I think about these problems. And I know that the sliding window is sometimes a subset of this, which is what I call contribution, right? And what I do is having for every number I go, okay, well, if this number is the last number in this subarray, how many prefix are there, right, that contributes to the answer? So for example, if you this is such a terrible example, but let's say you have like I mean, I'm just gonna just make up array, right? Maybe like just times it by 2 or something, right? So basically, if you go from left to right, right? If you go from left to right, oops, if let's say you're here, right? So 6, I mean, we do it for every number, but I'm just doing it in the middle, a number in the middle just for illustration. But it's going, well, okay, let's say 6 is the OR of this subarray, right? The right side of the subarray, the last element of the subarray. Well, how many left sides can there be that satisfy this condition, right? And then from that, I should be able to kind of like, I know what queries that I can do want, and able to kind of find this contribution to the final answer. Hence what I call the contribution idea, right? Or technique or whatever, right? And here, first of all, right, the first thing I would do is mod everything by the modulo, right? So here, maybe you want to rewrite it as, you know, 0, 1, 0, 0, zeros. Okay, there's a lot of zeros on this one, but that's fine, right? So now we're still here, right? And then I go, well, and this part I think is kind of oddly straightforward in the sense that, okay, well, actually we want the modulo is 3 is equal to k is equal to 0, right? Well, the thing is that we do know how many to the left side of this has 0 modulo 3, right? Here, this is the 3rd time that this has happened. It's kind of prefix sum, except for you don't even have to store the indexes specifically, right? It is just, yeah. Yeah, I think there is some, like, I have to be a little, I mean, yeah, I was just thinking about this edge case. I mean, I don't know if it's an edge case, but you have to be careful, is that if, but I think this only happens when k is equal to 0. But the idea that you have a 0, or not even 0, huh? Actually, maybe I do have to be a little bit careful. Maybe I am wrong, actually. No, I am wrong. Sorry. I was wrong about, I'm wrong. I'm a little bit wrong, but it has to be more precise. And what I mean by that is that I was wrong in the sense that you don't need to know anything in between, but it's because a subarray can contain elements that does not have anything in between, right? So what I mean by that is that if you're here, or maybe I'll just do another array, and you have to kind of consider it a little bit, but I think the idea is still kind of mostly true. You know, I'm a little bit wishy-washy. But for example, let's just expand the ones, right? Let's say we have a lot of ones here, right? And yeah, let's just say this case, let's just say modulo is equal to 4, k is equal to 0, right? So in this case, technically speaking, no, I'm wrong. I think my first time I was right. For some reason, I thought that, well, okay. I mean, I am right and wrong, but you have to be a little bit more precise still, right? And what I mean by that is that if you have something like this, okay, so, you know, if we want, what this is saying is that we want at least 4 and maybe 8, 12, we'll deal with that later. But for 4, let's just say we want 4 exact zeros, right? Because k is equal to 0. So you have, you know, your initial subarray might be this. This is one subarray, right? Hopefully you see what I'm doing with the highlighting. This is one subarray. This is a second subarray with 2 zeros on both sides. This is the 3rd subarray. And then lastly, this is the subarray. But you do have to extend this to go, well, it's here, and here, and here, and here, and here, and here, right? Because these subarrays all contain 4 zeros, right? So I think that part I have to be really precise about. So it is a little bit tricky, I think. Even though I think the idea is fine. We just have to be really precise with the implementation, right? And you can kind of see how, you know, there's a sliding window. There is a sliding window component, right? Which you can implement that way for sure, but you don't have to. I think the part that I'm finding a little bit difficulty, right, is that it's just this part. I mean, we can do stuff about like, I think we can handle it. It's just that maybe it's not that bad, because in this case, then you would just put you would put something called a degree of freedom on the zeros, meaning the number of non-zeros before, so that you can kind of extend to that way. And from then, if this is the left side of a thing, then you just sum it up, and I think that should be okay, right? You have to be careful, but I think that should be okay. This is kind of hard. I mean, I get the solution, but it's kind of hard, right? And the only other thing, right, is that, well, the other thing is that, well, I mean, this is good for this, but what if you have, you also want to have like 8 zeros, right? Like, for example, if you have something like this, you would have to kind of handle that in a good way, right? Because you can do this, which has, as we said, we can do this, right? So I'll draw it actually, right? So for example, this is a rounded subarray, right? And this is a rounded subarray, dot, 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 right? And then dot, 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 this, and all the way up to here or something. Pretty close anyway, I don't know, off by one, right? But now that it's multiple of 4s, right, with k is equal to 0, that's essentially what it's saying. You actually also want all these, every one of these, plus and extend it again. But I mean, that can be solved again, right? Because now you just count, okay, well, for each one of these, you have something like this, and then implement it, and then dot, dot, dot. Implementation wise, we can index them by offsets, right? Because the tricky thing is that you go, okay, well, if we have to go, okay, 4, 8, and then maybe 12 is somewhere on the left because we ran out of space, right? But if you kind of count them one by one, it's going to be too slow, right? But you could compress them by merging on the index of the zeros that we've seen so far, and I think that should be good. But like I said, this is really like annoying to get right. Not impossible, but just annoying, right? And I want to kind of talk the way that I've been talking through, because this is how I would solve this problem, and how I am solving this problem, right? Is that I'm doing this step by step by step by step as I'm talking it through. It may not be as fast as someone who's already solved it and pretend that it is perfect and just tell you the answer and be like, oh yeah, no, you do this, and this, but no, but these are the ideas that are coming in my mind. They're not always right, and as I kind of solve one component, you see me solve another component, right? Like I'm like, okay, well, if I have this thing with a sliding window, but oh no, there's an edge case that is like here, right? Then how do I handle it? And then now I'm like, oh, that's fine, but then now we have to handle this other case where you have multiple things. How do I handle that? So it's kind of like very iterative in that way, right? Anyway, okay. And sometimes, like now, which I may be right, may be wrong, is that now I have an idea of how to proceed. Let's get coded, right? I think for problems like this, sometimes it's also worthwhile to break it down a little bit more. And what I mean is that for k, this looks perfectly fine. And I think if k is always 0, I'm actually perfectly happy. I haven't analyzed the case where k is equal to 1 yet. It should have a very similar texture, similar idea, but it's going to be just a little bit off, right? Because I mean, I think it's mostly fine, but like, for example, this would be 5 instead or something like this, and then it'll be on 9 or something, right? 5 and 9 instead of whatever, right? So it should be very similar, but I think, like, test all the ones that you can test first, and then iteratively work on the other cases, and then but as long as you're confident that you're able to make or you only need to make small adjustments relatively, right? So yeah, okay. Yeah, so then now we have for I in range of n, and I is the right side of an interesting subarray, right? So what do we say? We want to keep track of. So for example, if num sub I, that's just no, it's fine. Modulo is equal to k. Then what? Then this is an interesting index, right? So maybe we write how do I want to represent this? I'm trying to think about. I mean, like we talked about all these ideas, and there are a couple of ways you can implement or like represent this as a data structure in code, either an array, lookup table, something like that. I'm just trying to think what would be the cleanest way, right? Yeah, and I want to write something like else, and then like maybe, okay, so we have a degree of freedom thing, which we talked about. So degree of freedom, we increment by 1. If this is true, then degree of freedom is 0. But only after we do all these other things. Technically, I think it's technically degree should always be 1, but we can always just offset it later. Okay, right? So then now so that's the thing, and then we also have current is 0, and this is just the number of let's just say relevant numbers we've seen so far, right? So relevant being just this part being true, right? If this is the case, we increment by 1, let's just say. And then now we can bucket, we could bucket the total number of degree of freedom of all the previous things that we've seen. So maybe we have previous is equal to, I wanted to say, I was going to allocate stuff depending on the modulo, but apparently modulo could go to 10 to the 9, so we'll just put in a lookup table, right? But no, I mean, yeah, I mean, you can also put it in an array because this is going to be dominated by n anyway, because obviously if current can only increment 1 per index, then yeah, it can only go up to n, so whatever, it's fine, right? Anyway, previous of current mod k increment by 1, right? Something like this. And I know that you could probably do the mod k before, but I think, oh sorry, this is before, but I mean like you could keep current under mod k, but I think this gives me a little bit more debugging power if I need to later. And let's change this to a counter so I don't have to do if statements on the non-existing power, right? So you have something like this. Actually, it's not even plus or equal to 1. It should be degree, right? Plus 1. Maybe we'll just start at 1 actually then, because that's how many degree of freedom you have for each one, and then you just kind of put it this way, right? And then the other thing we have is just total, which is the number that we're returning. And here, when this is true, we want to find other instances is true, which is, so then we just kind of sum up something like this. I think I'm kind of hand wavy here because I'm not confident. I'm too lazy to kind of think it through, but it should be roughly the right idea. I just want to run it to make sure that I didn't do anything too silly. Oh, k is equal. Oh, we're not modding by k. It's modding by modulo. I even said it correctly. I just kind of typed it incorrectly. Okay. I mean, this is fine. I said as the house is burning down. No. Okay. Right. Here we do want to say print out the previous. So we could just see, right? I mean, I know that I'm wrong on this case because k is equal to 0 means that if you have a non-zero for here, for example. Yeah, actually, I am wrong because this should be here, I think. Yeah, because you need to add this to the non-zero cases as well. I mean, this is the case that we talked about for example 2, where 1 and 1 is the thing, right? So you have to add it. Okay, so that was definitely wrong anyway, but maybe this will be less wrong, and it is not. It's surprising, huh? Let's see. 3 is equal to 0, so then here we have 0. Well, 0, 1, 2. Well, at the end of the 6. Oh, I think I added this wrong, or this should be afterwards, I suppose, because yeah. I need to do an additional one though, because I don't do the no empty initial array. So previous of 0 should be 1, or maybe or something like this. It's a little bit awkward, but I think something like that is a little bit more precise. At least for this one, it makes more sense. Maybe not, because this doesn't really make sense to be this. This should be this, I think. Yeah, okay. I think this is a little bit better. I mean, this makes this wrong, but that's okay. Now, let's see where it went wrong, though. Okay, so total. Well, no, this is a little bit. I think I needed to increment current, but this part has to be afterwards, right? Because otherwise you're just adding 1 to each index. So I think that's why it is wrong. Okay, maybe this has to be here. I think I also just tried too hard to kind of separate them. So maybe I can just do it this way. Yeah, so this is right. Let's double check. Even if it's right, you can double check your answers, right? So yeah, yeah. After one element, no. After one, so this should be what I would expect this to be. Like I said, initially I only focus on k is 0, 0 because it's just a simpler problem. So now this is k equals to 1. So then we may have to kind of reanalyze this a little bit better. Yeah. Yeah, I think, yeah, this is this ordering thing, it's the tricky part, right? So what I'm seeing from the debugging purposes is that basically I'm skipping the this 3 and 1 element with only 3 case, which I don't handle for sure. I mean, for sure I do not handle it. But also, no, I mean, maybe I do, I don't know. But this is also wrong, I think, because this is saying, okay, this is 1. We're looking for, I mean, okay, so this part is right? But this part is definitely wrong. Or this part is correct for k is 0, 0, because just of the way the math works, but it's not for 1, right? Because you're not, when you are at 1, you're not looking for 1, you're looking for 0. Because that's where the k comes from. So there is a k component of this, and when k is equal to 0, that's why it works, because, well, I didn't mention it. But here, it actually should be current minus k, I think. Right? Yeah. And the reason is because if the current is equal to 1, then you're looking for 0 so that the delta is 1, right? Which is 1 mod 2 in this case. And if the current is 2, you're actually looking for 1, because 2 minus 1 is going to be 1 k, or k equal to 1 mod 2 in this case, right? Okay, am I super confident about it? Honestly, not really. I mean, there are only 2 examples, and I think in general, especially if you're on an interview, I would talk about, and actually do maybe, just adding more test cases and stuff like that. Actually, let me put in this one, I suppose. But but we do have a benefit of having able to connect it to the right answer, because on an interview you would probably have to figure out what the right answer is, right? For that answer. But here, ooh, nums can, oh, because okay, fine. Same thing, but it has to be non-zero. That's why. I would say, ooh, okay. I was gonna say if this works, I'm a little bit more confident, but clearly it does not work, so I'm not confident now. Let me double check the 0 case as well. I mean, obviously, when you get a wrong answer, is definitely. But that's one of the thing, right? Is that if I didn't have the correct answer in front of me, like for a contest, then I would not know that this is wrong. So it's a little bit trickier. But I would have been inclined to YOLO just because, why not? Okay, so even the 0 case is wrong. So that's actually, for me, a little bit more concerning. Is either that or did I do this math wrong? Maybe this is a plus k. Nope. Okay. But it is, well, because k is equal to 1, so plus and minus k is the same for mod 2. I I guess I should have just, no. Current minus previous is equal to k, so yeah. This should be right though. But I was just like, maybe it's an easy try. But yeah, I think this one is easier to debug, so we can see, right? So after the first 3 elements, nothing. This being a thing is a little bit sketch. Oh, this is wrong. I see. I mean, this is saying that after 4 elements, so this. Yeah, it's saying that this is an interesting subarray, which is not true. The reason is because here, so maybe this part is not right. This is a struggle for medium. It's either that or there's an easier way, and I'm just like doing it in a really dumb way. But maybe I don't need the degree of freedom thing. What am I doing wrong? Hang on, sorry friends. This is the part where we're struggling, but you know, I think we're on the right track, but definitely not great. But the reason is that it's saying that after, or maybe after 5 elements. Yeah, after 5 elements, it is because it maps the 3 to the 3, right? Well, we don't increment, but because the current is 3 mod 4, and so it was adding it from the previous 3 mod 4. I think now that I see it this way, because I think I'm trying to play too much on this one. I think I don't need the degree of freedom actually, because then I can just put it here, and then there's an implicit thing here, right? So then I can just do this, and then maybe this, something like that. Maybe that's a little bit okay. I think I was playing around with the degree of freedom, because the reason why the degree of freedom thing is wrong is that I messed up. Is the short answer, but because now that I'm doing it one by one, I noticed where I'm missing it, right? And sometimes that's why you have to walk through a case, because I was focused on the case where I'm extending, you know, here, right, or whatever it is. But I think what I forgot to handle as a result, and I kind of hand waved this, maybe I thought about it, but I didn't really think about it hard enough, is handling something like this side, right? So let's say you have, something like this, and as a result, and it's not just this, right? Because it's this and the same length, but plus one more thing, right? And so, and once you kind of visualize it like this is a very common thing that you could see, is that then now, and this is the same thing, right? We're saying if this not one is the right side of the subarray, then what is the contribution? And that's why this idea is so powerful, even if I misused it this time, is because then now you do not have to make special cases for both the left side or the right side, because then now you know that this index, and when I did this degree of freedom thing by merging all this to here, it only focused on these numbers on the left side and not on the right side. Which is actually mostly right, I think, but by the same idea, if you wanted to do it this way, then you have to kind of, there are 2 ways to do it, right? One is whichever I just did here, but then the other is that what is the contribution of 1? Then you just kind of add this to the same number of the last 4 that you've seen, which is all more bookkeeping, but also the same idea in a good way, and that's the cleaner way, right? Because as you can see, this code is so much cleaner. Did I submit it? I actually don't remember. Let's give it a submit then. Maybe not. Okay. But yeah, this is, I don't know why this is trickier than it is usually for me. I feel like I'm usually pretty good at this actually. But Yeah, but some days you have good days and some days you have bad days. And this took half an hour. Jeebus. What did I do last time? Last time I just did prefix sum and then, yeah, I don't know. I guess last time I was just much smarter. I don't know. Or maybe I did way similar problems. I was confused about this double level thing, and I got caught a little bit on the wrong side of that thing. But yeah, I think I got a little bit caught up on the 2 layers of modular. It's kind of confusing because I think because in general, otherwise this is actually pretty common. But okay. Well, let me know what you think. And if this video is too long for you, maybe, well, I wish I said at the beginning, then watch the other video and maybe I explained it a little bit better in that video. I don't know that I did, but maybe I did. I don't know. Maybe I'm just getting worse by the day. But yeah, that's all I have for this one. That's all I have for right now. Thanks for watching. And oh yeah, I forgot about complexity, but I mean, this is linear time, right? And linear space, technically modular, but okay, right? That is all I have. Thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.